Hi dear student, welcome to the session. In this session, we are going to discuss the numericals from the unit 5 and 6, which includes the chapter Magnetism and Matter, Electromagnetic Induction, Alternating Current and Electromagnetic Waves. So maximum you can expect the question from Alternating Current and Electromagnetic Induction. So let's start with this question number 1. This question is asked in March 2014 from the chapter Alternating Current. Okay? It says calculate resonant frequency and Q factor of a LCR circuit, series LCR circuit, a circuit which includes inductor, capacitor and resistor. So resonant frequency and Q factor containing pure inductor of inductance 3 Henry. Usually write the inductance circuits, inductor, capacitor and resistor, which is connected to an alternating source, so which is indicated like this, series LCR circuit LCR, and they say a pure inductor of inductance is L is equal to 3 Henry. So L inductance is represented by L, which is equal to 3 Henry given. Capacitor of capacitance, so that is C, capacitance is represented by C, which is equal to 27 microfarad. So microfarad, I write it as 27 into 10 to the power, micro refers to -6 farad, and a resistor of resistance is represented by R, which is equal to 7.4 ohm. So this is the data given, and they are asking us to calculate the resonant frequency, which is represented by omega naught, or you can also write it as f naught, mu naught. So omega naught to be calculated, and the Q factor, a constant which is related with respect to the LCR circuit, that is omega naught and Q factor. Omega naught, the resonant frequency, we have the expression omega naught is equal to 1 by root LC. So L is given, C is given, let's find it out. So 1 over root of L, how much? 3 multiplied by 27 into 10 to the power -6. Okay? So then 1 over, you can see 3 into 27 is 81 into 10 to the power -6. And let us say 81, it's a square number of 9. So 10 to the power -6, if you take square root for 10 to the power -6, that is 10 to the power -6 whole to the power 1 by 2. So it will become 10 to the power -1. So -3 is going to be 1 over 9 into 10 to the power -3. So you can write as 10 to the power 3 is taken to numerator, that becomes 1000. 1000 divided by 9. So this is coming out to be 11.11 radian per second. 111.11 radian per second. We can also calculate this one in hertz using the formula F naught is equal to, or FR, resonant frequency, that is 2.2 square root of L by C. Okay? So we have calculated the resonant frequency. Let's calculate the Q factor. Q factor is a constant. Let's find it out. Okay, Q factor, Q is equal to omega naught L divided by omega naught L divided by R. So omega naught is 111.11 we find is the Q factor. And Q factor doesn't has any unit. So it's a direct question. We should know the concept. Basically, resonant frequency means it's a situation when the LCR circuit becomes completely resistive. So that is XC is equal to XL. That is inductive reactance is equal to capacitive reactance, which will lead to the concept of resonance. So we get omega naught divided by root LC. So once we know the concept is when we know the concept, so we can easily solve it. Let's move on to the next question. This question is again from the alternating current. It says a pure inductor of inductance 25 millihenry. Inductor of inductance 25 millihenry. So that is inductance is given by N, which is equal to 25 millihenry. So milli is 25 into 10 to the power minus 3 Henry. Is connected to a source of 220 volt 50 hertz. So only here the inductor is connected. Inductor is represented in circuit as like this. So which is connected to a source, AC source. This is L of 220 volt, 50 hertz. Okay. Find the inductive reactance. Inductive reactance is represented by XL. Inductive reactance, RMS value of current, that is I RMS. Then peak value of current, so that is IP, or you can also represent it as I naught. So XL, which is inductive reactance. So inductive reactance, we have a formula. XL is equal to L omega. XL is equal to L omega. So L is how much they have given it as 25 into 10 to the power minus 3. Omega is 2 pi f. 2 pi f. So I can write here omega is equal to 2 pi f. That is 2 into 3.14, that is 22 by 7. F, that is 50. So 2 into 50, 100. 3.14, that is 314 per second. I substitute the value here. 314 radian per second. So 314 into 25 is 7,850 into 10 to the power minus 3. So we can write as 7.85. So inductive reactance, that is inductive reactance is the resistance in pure inductive circuit. So inductive resistance, reactance is the resistance in pure inductive circuit. So the SI unit is ohm. So unit is ohm. So we got XL. We need to calculate the IRMS. So the current here in IRMS, using the Ohm's law, we have IRMS current will be equal to the voltage V of the source divided by the resistance in the circuit, that is nothing but inductive reactance. So the source voltage is 220. They have given it as 220. So 220 divided by 7.85. So we get as 28.132. 28.132 amperes. So IRMS is equal to 28.132 RMS. Now the peak value. So we need to calculate the last one, the peak value. How the RMS value and peak value are related? It is I naught is equal to root 2 into I on Ms. So root 2 is 1.414 into 28.132. So get it as 39.78 amperes. This is the peak value, that is I naught, peak value of the current. So we have calculated the required things of the numericals. This is simply an inductive circuit. They have given the inductive circuit and asking us to calculate the inductive reactance, Rms current in the circuit, and I naught. Okay, let's move on to the next question. This is the question number 3. I am discussing now from March 2015. Again, the question is from alternating current. So let's continue. A sinusoidal voltage of peak value, that's AC voltage of peak value 283 volt. Okay. So sinusoidal of peak voltage, I call it as V is equal to 283 volt. And frequency 50 Hertz. The source frequency is 50 Hertz, that is F is equal to 50 Hertz, is applied to a series LCR circuit, which is applied to a series LCR circuit. So we can take it as L, C and R. So the source we have applied, they have given, that is 283 volt, 50 Hertz. Yeah, this is L, C and R. Okay. In which R is equal to 3 ohm. So they are giving R as 3 ohm, L is equal to 25.48 millihenry is given. So that is 10 to the power minus 3 Henry, and C is equal to, that is capacitance, C is equal to 786 microfarad, that is 10 to the power minus 6 farad. This is the total given. Find impedance of the circuit. What is impedance? How we represent, that is Z. Impedance is known as the resistance in the LCR circuit. Resistance in LCR circuit, that is represented by Z. We need to find it out. The phase difference between the voltage across the source and the current, that is phi. Phase difference between the voltage across the source and the current. Then the last one is power factor. Power factor is represented by cos phi. So we need to find out the value of cos phi. So let's find out the values one by one. Z, the impedance in the LCR circuit. We have formula Z is equal to square root of R square plus XL minus XC whole square. XL minus XC whole square. This is the formula for impedance in LCR circuit. But here R we know, but XL, XC we don't know. Let's find out their values. XL is inductive reactance, which is given by L omega. So L is 25.48 into 10 to the power minus 3. Omega is 2 pi f. So 2 pi f is 314. I am writing it directly because omega is 2 pi f. 2 into 50 into 3.14. So that is 314. So 314 into 25.48. So you get it as 8,000.32 into 10 to the power is 8 ohm. We get it as 8 ohm. XC. So this is the capacitive reactance, that is resistance in a capacitive circuit, is given as 1 divided by C omega. 1 divided by C omega. So this is going to be 1 over 786 into 10 to the power minus 6, that's the capacitance, into 314. So this becomes XC is equal to 10 to the power 6 divided by 786 into 314, which is going to be 2,46,804. So what is 10 to the power 6? That is 10 lakhs. Okay, that is 10 zeros. 10 to the power 6 divided by 246,804. We get it as 4.05. We get the value as 4.05. The value 052. I'm rounding it off. Again, the resistance XC is equal to 4.052. Now let us move on to the next one. XL we have, XC we have. Let's find out the Z. So Z is equal to square root of 3 square, R square. R they given it as 3, so 3 square that becomes 9. 9 plus XL. What is the value of XL? That is 8. 8 minus XC. That is, you can take it as 8 minus 4.052. So that is within the bracket 3.948 square. So let's find out. So this value is going to be 9 plus 3.948 square is 15.586. So the value is going to be 15.586 plus 9, 24.586. So we take the square root of the answer. I am going to write it directly. So we get it as 4. Z on solving, adding the values and taking the square root for it. So we get 4.95. 4.95. So again, the unit of impedance, that is the resistance in the LCR circuit, is going to be ohm. So now we calculated the first one, that is impedance of the circuit. Impedance of the circuit. Let's go for the next one. One more thing, what we can do here is, instead of taking it as 3.948, so you can reduce this value as approximately 4, taking it to 4. So what happens? 8 minus 4 is going to be 16. Square, when you square it, 16. So this is going to be 25. And the final I can take it as 5 ohm. So let's proceed. The phase difference between the voltage across the source and the current, that is tan phi. I use the factor tan phi, which is equal to XL minus XC divided by R. XL minus XC divided by R. So this is going to be 8 minus 4, 8 minus 4, that is coming out to 4 by 3, this will be 1.33. So phi is equal to tan inverse of 1.33. We get it as 53.129. Okay. So we got the value phi, that is the phase difference between the voltage across the source and the current. The last one we need to calculate is the power factor. Power factor is given by cos phi directly, which is going to be cos phi R by Z. The value is R by Z. R is the resistance in the circuit, that is 3 ohm. The Z we have calculated as 5. So 3 by 5 is going to be 0.6. So directly the power factor, you cannot take 5 here. This is power factor is completely cos phi. So that is 0.6. So we have calculated the three values they were asking for. The first one is impedance, then the phase difference, and the power factor. Power factor is given by cos phi. Bit lengthy, but it is an easier one. So impedance, we should know the formulas, then we can able to solve the numerical. So let's move on to the next question. And the question is from alternating current. Yes? Let's solve this. A resistor of 100 ohm. Okay, let's collect the data. So a resistor of 100 ohm. So resistor is represented as R is equal to 100 ohm. Next, pure inductance coil of N is equal to, there is pure inductance coil of inductance, inductor coil of inductance. N is equal to 0.5 Henry, that is H, and capacitor C, they have not given. Let's place the question mark. In series, so they are connected in series. In a circuit containing AC source, so AC source of voltage 200 volt and frequency F is equal to 50 Hertz. Then in the circuit, current is ahead of voltage by 30 degree. So current is leading the voltage by 30 degree. So what does this represent? This is the phase difference between the voltage and the current, that is phi. The value is phi, which is equal to 30 degree. They have given the phi is equal to 30 degree. And find the value of capacitance. Okay, we need to find out the value of capacitance. Yeah. So let's see what is the how we can able to find out the value of capacitance. If you ask me, so one way in an LCR circuit, I can use the formula XC is equal to 1 over C omega. XC is equal to 1 over C omega. But omega, that is 2 pi of 340, 2 into 50 into 3.14. C, we need to find out. I can take this one here, XC to this side, but we don't know the value of XC. How that XC can be calculated? If you have a look at the data, resistance is there, inductance is there, and the frequency and phi, especially this value. So what is the relationship between the phi and XC? If you ask me, obviously it is going to be tan phi is equal to XC minus XL. XC minus XL or XL minus XC whole divided by R. XC minus XL divided by R is the formula which relates the things. So let's substitute. tan phi, that is tan 30, and xc as it is I write minus L xl is written as L omega whole divided by R as it is I write. In the next I am going to substitute the value. I can write this expression as xc minus L omega, which is equal to R into tan 30. One more step, I can take xc is equal to R tan 30 plus L omega. So this is the xc, I will get it here. So finally I can calculate the value of c. So xc is equal to R. What is the value of 100? 100 into tan 30. So tan 30, what is the value of tan 30? Sin 30 is 1 by 2, root 3 by 2. Tan 30 will be sin by cos, it's 1 by 2 by root 3 by 2. So it's going to be tan, okay, we take it directly, 0.5773. Tan 30 is going to be 0.5773, making use of the Clark's table in which we go for natural tangents. So get the value, tan 30 is equal to 0.5773. L, the value of L, so here we have addition. L is 0.5. Omega, that is 314. So 100 into 0.5773 becomes 57.73 plus half of 0. Okay. Okay, 0.5, 314 is going to be 157. So 157 plus 57.73, 214.73 ohm, because xc is capacitive reactance. Then I have given the information xc can be written as 1 by c omega. We need to calculate the c. So the formula will be c is equal to 1 over xc into omega. This is going to be 1 over 214.73 into 314. Okay. So C is coming out to be 1 over 67,425.22. Okay. 1 divided by 67,425.22 is going to be 0.40148 farad. So I can write it as a shift 6 digits 1, 2, 3, 4, 5, 6. So C is equal to 14.8 into 10 to the power minus 6 farad. Finally, C is equal to 14.8 microfarad. So 10 to the power minus 6. So we get the value as. So they have asked us to calculate the capacitance in the series LCR circuit. One basic way we need to follow is collection of data and how it is related to the value we need to be calculated. So we have collected the data given in this question and related it to the quantity that we need to calculate here. So they are asking for the capacitance. We use the information they have given and we check how they are interrelated. We can calculate the given value, that is capacitance is 14.8 microfarad. Okay, dear students, let's continue with the question number 5 from the unit 5 and 6, which includes the chapters magnetism and matter, electromagnetic induction, alternating current and electromagnetic waves. So that is unit 5 and 6. This present question is asked in March 2016 and is from alternating current. Let's solve this. Calculate the resonant frequency. Calculate the resonant frequency, which is represented as omega naught. And Q factor of a series LCR circuit. So omega naught we need to calculate, and also the Q factor, which is represented as Q of a series LCR circuit containing a pure inductor of inductance. So which contains a inductor of inductance. L is equal to 4 Henry, comma, capacitor of capacitance, that is C is equal to 27 micro, I write it as 10 to the power minus 6 Henry, and resistor of resistance, that is R is equal to 8.4 ohm. 8.4 ohm. Okay. So omega naught is a direct question. Omega naught can be calculated by the formula. Omega naught is equal to 1 over root LC. So 1 divided by root L is 4 into C, that is 27 into 10 to the power minus 6. This is going to be 1 over square root of 27 into 4, 108 into 10 to the power minus 6. So take the square root of answer. 10.39, 1 over 10.39, and taking square root for the 10 to the power minus 6, it is going to be 10 to the power minus 3. As this shift upwards, this becomes 1000. So omega naught right here, 10 to the power 3, that is going to be 1000. Minus 3, I am shifting it upwards, becomes positive. So 10 to the power 3 means 1000, which is divided by 10.39. Okay? We are getting it as 96.24. 96.24 radian per second. Radian per second. You can also calculate the resonant frequency in terms of hertz. That is F is equal to 1 over 2 pi into root LC. So you can also calculate this thing. What do you get? 1 by root LC we have 96.24. So 96.24 divided by 2 into pi, that is 6.28. We get it as 15.32 hertz. 15.32 hertz. That is F is equal to 1 over 2 pi into root LC. So we have calculated the resonant frequency. Now the Q factor. Q factor is given by the formula omega naught L divided by R. So what is the value of omega naught? That is 96.24. L, what is the value of L they have given? L is 4 Henry. 4 divided by R, that is 8.4. Okay. So 96.24 into 4 whole divided by 8.4. We get it as 45.82. So the Q factor 45.82. Okay dears, this question is similar to the question which is asked in March 2014. The only change is that this was 7.4 in that one, and here we had 4 Henry only. No, I think 3 Henry. So variables has been changed, the values, given values has been changed, but the solution, the quantities they are asking and the formula that we need to use are same. So result frequency and quality factor in a series LCR circuit is one of the important factors to be calculated. Yes, let's move on to the next question. So dear students, let's continue with the numerical number 6 from the units 5 and 6. This question is asked in June 2016, and very interesting one, numerical, from the chapter Alternating Current. So get to know why I am saying it is interesting. It's what we have discussed up to now, numerical 5. This is very different from that. So here an inductor, so they say an inductor and a bulb are connected in series. Okay, inductor that we know L. What is a bulb? Bulb is nothing but a resistance. So it has a device which has a resistance. So here they say a bulb, that means they are giving a resistance, are connected in series to an AC source of 220 volt 50 hertz. So let me write an inductor. So we have an inductor, a bulb. So that is nothing but the resistor. This is L, this is R, which is connected to an AC source of, so AC source 220 volt, 50 hertz. Okay. A current of 11 amperes flows in the circuit. So that is I is equal to 11 amperes in the circuit, and the angle between the voltage and the current, that is phi. That is the limit. Phi is equal to pi by 4. The phase difference is pi by 4 radians. Calculate the impedance. Impedance means the resistance in the circuit, that is Z, which is represented as Z, and the inductance of the circuit, that is L. Inductance of the circuit need to be calculated. So L and Z we need to calculate. Okay, here Z we need to calculate it directly in this case. Z is the resistance in the circuit. So using the Ohm's law, V is equal to IR, R is replaced as Z in this circuit. So Z is written as voltage by the current in the circuit. Z is equal to V by I. This is going to be 220 divided by 11. So we get the value 20 ohms. So Z is the impedance. Impedance is the resistance in the circuit. That is series, inductance and resistance. LR circuit we can generally say 20 ohm. So we got the impedance as 20 ohm. Let's find out the L. Inductance. We need to find it out. So generally what we have the formula is XL is equal to L omega. XL is equal to L omega. So we don't know XL here, we know this omega value, and then we need to find out. Okay, let's try to find out XL. What else quantity they have given? They have given phi. So phi, where we can use it? So we have the formula tan phi is equal to XL divided by R. XL divided by R. So So you might have expected that where is XC? We don't have it here because we don't have the capacitance here. So we ignore writing that. The equation becomes XL by R. So tan 45, that is tan pi by 4. Tan 45 becomes, its value is 1. So I can write this is going to be 1 is equal to XL by R, which implies XL is equal to R. XL is going to be, the value of XL is equal to R, that is resistance. Let's calculate that value. What we have? We have the formula Z is equal to square root of R square plus XL square. R square plus XL square. So R, we don't know. XL can be written as R. So what happens? Square root of R square plus R square, that is 2R square. So this becomes root 2 into R. Root 2 into R. So Z we have calculated. That is the impedance, that is resistance in the circuit. So finally I get R is equal to Z divided by root 2, that is 20 divided by 1.414. So get the value as 14.14. This is the resistance of the circuit. Resistance of the circuit. So let's find out the value of inductance using this R in this equation. Because you see, XL is equal to R. XL is equal to R. So using this equation, XL is equal to L omega R. L is equal to XL divided by omega. We can write it as XL is R by omega, that is 14.14 divided by 314. So 14.14 divided by 314 is going to be, so I write here final value, L is equal to 0.045 Henry, or you can also write L is equal to 12345 milli Henry 10 to the power minus 3. So they are asking us to calculate the impedance. We have calculated it here. Then they are asking us to calculate the inductance. I have calculated that value also. So it takes time. So go through the basics, make use of the data given, so you can able to calculate the required value. So here I am using the value of impedance as V by I, and also I am using the value where Z is equal to square root of R square plus XL. So both are valid. Here I can calculate the value of impedance according to the given data. Here I am using the impedance formula to calculate the resistance in order to calculate the inductance later. So make use of the data and use the respective formulas to calculate the required values.